Hey everyone, welcome back to the Mindverse. Today we're exploring one of the most mind-bending ideas in all of science and imagination. It's something that has fascinated humanity for centuries, something we've seen in movies, novels, and even ancient myths. We're talking about time travel, the possibility of moving through time in ways far beyond our everyday experience. Is it real? Is it possible? And if so, how close are we to achieving it? Let's dive into the science behind one of the most incredible questions we can ask. Time feels so ordinary to us. We wake up, live through our day, and drift into tomorrow, always moving forward. We can remember yesterday but not return to it. We can imagine the future but not step into it before it comes. Time feels like a river carrying us in one direction. But science has revealed that time is not as rigid as it seems. The universe may allow us to stretch it, bend it, and maybe even loop through it. Albert Einstein changed everything we thought we knew about time. Before him, most people believed that time was absolute, ticking the same way for everyone everywhere. But Einstein's theory of relativity revealed that time and space are woven together into one fabric. Space-time and space-time can bend and warp depending on gravity and motion. That means time doesn't flow the same for everyone. It can actually run faster or slower depending on how you move and where you are. This discovery opened the first scientific door to time travel. According to Einstein's special relativity, the faster you move, the slower time passes for you compared to someone standing still. This effect is called time dilation. It has been tested and confirmed many times. For example, astronauts orbiting Earth at incredible speeds on the International Space Station age slightly less than people on Earth. The difference is tiny, just fractions of a second, but it proves that time doesn't pass the same everywhere. In a sense, astronauts are already traveling into the future, even if only by milliseconds. Now imagine what would happen if you could take this effect to the extreme. If you traveled close to the speed of light in a spaceship, time would slow dramatically for you. You could experience only a few years, while centuries might pass back on Earth. This is one of the most straightforward scientific ways to travel into the future. The technology to reach such speeds doesn't exist yet, and the energy required would be almost unimaginable. But physics doesn't forbid it. It means that traveling into the future is not only possible in theory, but guaranteed by the very laws of the universe. But going backward in time is where things get complicated. Traveling into the past creates paradoxes that seem impossible to resolve. The most famous is the grandfather paradox. If you went back in time and prevented your grandparents from meeting, you would never be born. But if you were never born, how could you go back in the first place? These contradictions make backward time travel one of the strangest puzzles in all of science. Still, Einstein's general theory of relativity doesn't completely rule it out. His equations suggest that under extreme conditions, space-time could form loops that allow a traveler to return to an earlier point. One possible way is through wormholes. A wormhole is a theoretical tunnel connecting to points in space-time. If such tunnels exist and could be stabilized, they might allow travel not just across space, but across time as well. By moving one end of a wormhole at near light speed, and then bringing it back, a time difference could form between the two ends. Stepping into one side could mean stepping out at a different time. The challenge is that wormholes, if they exist, would collapse instantly, unless held open by exotic matter with negative energy, something we haven't discovered yet but that quantum theory doesn't completely rule out. Black holes present another fascinating possibility. These giants warp space-time so extremely that time slows near their edges compared to the outside universe. Some theoretical solutions even suggest that a rotating black hole might allow paths through space-time that loop back in time. The problem is obvious. Getting close enough to a black hole to use it would be fatal. The gravitational forces and radiation would destroy anything long before it could attempt a journey. But on paper, the equations allow the possibility, and that keeps the idea alive in physics. Other exotic concepts include cosmic strings, hypothetical remnants from the early universe. These thin, dense objects, if they exist, could warp spacetime enough to allow closed loops in time. No evidence of cosmic strings has been found, but they remain one of those ideas that scientists keep in the toolbox when thinking about how the universe might work. The paradoxes of time travel have inspired some clever solutions. One is the Navikov self-consistency principle, which argues that time travel to the past might be possible, but events would always adjust themselves to avoid contradictions. For example, if you went back to prevent your grandparents from meeting, circumstances would somehow intervene to make sure they still did. You would become part of history, not someone who could rewrite it. The past would be fixed, and your actions would already be woven into it. Another idea is that of multiple universes. If you went back in time and changed something, you wouldn't erase your own timeline. Instead, you would create a new branch of reality, a parallel universe where events unfolded differently. This concept fits with some interpretations of quantum mechanics, where multiple possibilities exist until one is observed. In this view, time travel is less about rewriting history and more about jumping between different versions of reality. As exciting as all of this sounds, the practical challenges are overwhelming. Traveling near the speed of light requires energy far beyond what we can currently produce. Wormholes, if they exist, might be impossible to stabilize. Black holes are too dangerous, and cosmic strings remain hypothetical. Even if the universe allows time travel, achieving it would require technology and understanding far beyond anything we have today. But here's the fascinating part. Physics doesn't completely forbid it. That alone makes time travel different from many other impossible-sounding ideas. The fact that relativity, quantum theory, and cosmology all leave tiny cracks open for time travel keeps scientists intrigued. Every time we test relativity with high-speed particles or measure the behavior of clocks in extreme conditions, we're learning more about the strange reality of time. Maybe time travel won't look like the science fiction stories we love. It might not involve machines that let us jump freely backward and forward. Instead, it might involve more subtle effects, like sending messages into the future using quantum entanglement, or using time dilation for long-term space travel. Or perhaps it's about realizing that we're already traveling through time, all of us together, moving forward into the future 1 second at a time. What makes time travel so powerful as an idea is that it doesn't just challenge physics, it challenges our understanding of ourselves. Time is what shapes our lives, our memories, and our hopes. To question whether it can be bent or broken is to question reality itself. Whether we ever build a time machine or not, the pursuit of time travel has already reshaped our view of the universe. So the next time you glance at a clock or look up at the stars, remember that time is more than just ticking seconds. It's a mystery at the heart of reality, one that might hold secrets we've only begun to imagine. Time travel may not be here yet, but the science behind it is already transforming the way we see the cosmos. And maybe, somewhere in another time or another universe, someone is already looking back at this very moment as part of their own incredible journey.